Please give a warm welcome to CEO Damion Shelton, CTO Melonee Wise, and our special guest, Digit.
Hello. Thank you, everybody, for coming. So, robots with legs seem to have had a really slow start, but suddenly they're absolutely everywhere. Now, humans are pretty neat. We have all these arms and legs and stuff, but planes don't have legs, cars don't have legs. Why do robots need legs?
I think the short answer is because our environment is constructed around us. So if you think about requirements documents, you can kind of run that both forwards and backwards. And if you start for an environment that was designed for people, a robot that can move easily through that environment would end up with arms and legs.
So the stage was built for humans. Shall we see if Digit can join us out on stage here?
Sure.
Yeah, sure.
Awesome. So while Digit is strolling out on stage, I noticed, so I met one of the robots the other day, and I noticed it seems like it has eyes. Why does it have eyes?
Yeah, that was a controversial decision, actually, with the original Digit V3 that we started selling 3 years ago. Some people saw it as not having a head. I was in the it had a head camp. But then when we were looking at the human factors side of it, one of the nice things with having the eyes is it gives you a sense of where the robot's about to go. So if you actually watch it when it turns, it's going to kind of look in the direction of where it's going. It can blink, it can do other gestures, and that gives you a nice human factors interface to the robot.
Right. But it doesn't actually use those things to look, right? There's sensors all everywhere, so it's a communications tool.
Correct, yeah.
Like how does that show up in terms of how it kind of moves around and and greets people and interacts with the people around it?
Yeah, I think that when you look at Digit, the human-robot interaction concerns that we care about are around making people feel comfortable and I guess connected with the intention of the robot as much as possible.
Yeah.
So that's why Digit has eyes, obviously, but also it helps to direct the human gaze to areas of the robot that are important for them to care about. For example, the LED ring that's on the sides of the head and things like that, so that people see Digit is in a good state and excited to be in the world, right?
Right.
And I think that as Digit does more things with our customers in the world, these capabilities will evolve
Yeah.
to help communicate different things to the customers.
So talk me a little bit through the gestures and things it's doing right now. Like what do these represent to you as a roboticist?
Yeah, I think that when you look at Digit, Digit is really built for work, and it's built for work in logistics and manufacturing facilities. And so a lot of the different capabilities that Digit has are to accommodate those environments. So being able to reach very high, being able to crouch down very low, being able to move its arms in a way that allows it to reach around big things. And all of these things are super important. You know, as someone who spent 10 years in the AMR industry building mobile robots without legs,
Right.
There's quite a few limitations that you start to run into with statically stable robots. And with Digit being dynamically stable, we're able to reach a lot more of the workspace of the facility that people can reach.
Right. And so you talk about spaces that are built for humans that this robot is good at interacting with. And in a lot of spaces, obviously, they're kind of mostly built for robots, right? It's for robots to roam around. So is this a stepping stone towards something else? Or do you think that these types of robots are needed throughout the kind of...
Yeah, I mean, I think, you know, a question we got early on is, do you imagine Digit grabbing something and then running down an aisle carrying it?
Right.
And I think in most practical deployment scenarios, you're actually looking at sort of a heterogeneous robot deployment. So Digit would work alongside an AMR, which is, of course, Melonee's whole background. It would work with other static fixed pick-and-place robots, right? So the goal is to infill automation right now in ways that can only be done with people who have a high injury rate. This is an industry that has historically very high underemployment, in fact, growing underemployment as the push for logistics increases. So very much this is a part of a universe of solutions, but not by itself the complete solution.
All right. Shall we wave goodbye to Digit, folks? Bye, Digit. Thought so. Goodbye. So what was the hardest part about what we see in front of us here? Like, what was the biggest challenge of developing a robot like this?
What's the hardest part? What's the hardest part for me or the poor engineers who actually have to build the robot?
Yes.
You know, I think what was interesting, you know, our first time at TechCrunch was at the robotics sessions, I think 5 years ago.
I was there.
And that was with the Cassie robot. And so I think what we had to do was plan out a structured approach of starting with what was unapologetically not a commercial product, right? We sold it to academic R&D, and we had to kind of figure out a way to ladder ourselves up all the way to now a generation of robots that's deploying into customer environments. For me, that whole long arc was the hardest piece, but.
Yeah, and we're now just starting the ramp to the really, really, really hard part, which is productization, right? It's one thing to do something well once. It's another thing to do it well at 99.98% of the time.
Right.
And that's a strong and long ramp, and we're excited to be on it. And that's the biggest thing, and that's why we had the announcement of the RoboFab this week.
And so for context, I wrote about it, but you were there, so what is a RoboFab?
Yeah, so that's our new facility that we're opening in Salem, Oregon, which is north of our current engineering facility by about 30 miles. It was a building that we happened to intercept at the right time in its construction. So we started this project about a year ago. And the reason, if you've ever done home remodeling, it rarely finishes in a year. In this case, we happened to get in with the landlord at the right time to bring the facility online. Right now, we're in the process that a lot of EV makers go through early in their life, where you're going from initial mid-volume hand-built robots up to a transition to a line approach, which is what we're doing later this fall and through the spring with the beta version of Digit version 4.
Yeah. Are digits being used to build digits?
Not yet, but we are going to be using them to carry totes around in our facility. So we do kitting when we hand off to the techs the parts list to build the robot. That goes into a bin. Turns out one thing Digit's very good at is building or moving bins around facilities.
Yeah. What's the how much can it lift? How high can it lift things?
Yeah, so if you look at Digit today, Digit can lift about 35 pounds. It predominantly moves totes. It can get up to 1.4 meters, and it can get down to basically the ground in terms of its ability to reach and grab things.
It seemed like it was reaching much higher than 1.4 meters just now.
Yes, it was, but I think the thing is that when you look at even 1.4 meters or 2 meters, like OSHA has some limitations on how much weight a person can lift, and so even though Digit can do those really high lifts, we most likely wouldn't encounter those lifts in a facility that was built with people in mind.
Right, that makes sense. That makes sense. So, like backstage, there was somebody making a joke about Skynet, and I'm sure you get those 7,000 times a day.
Definitely not. Never happens.
Yeah, never happens. I thought so. But weaponization of robots and stuff is a conversation that people have a lot. And I know you guys signed a pledge.
Sure, yeah.
What was that pledge and why?
Yeah, so we actually know the folks at Boston Dynamics really well. This is a relatively small community, and we had started talking with them about a year and a half ago and started talking through what do we want to see the industry evolve into. And something that all of us are quite sensitive to is the desire to not have a robot ever hurt someone, whether accidentally or intentionally. The easy thing to prune off is like no intentional hurting of people. There's just no reason to do that. It doesn't help the industry. Life, it's very hard to see a universe where intentionally hurting people is on that roadmap.
Yeah, I mean, I think I would be proud of you. What does that actually specifically mean? Does it mean not attaching a weapon to a robot? Like, what is the pledge? What are you pledging?
So, just not attaching a weapon to the robot, not using the robot in any way that could harm people or animals or even be threatening.
Yeah. And so why is that important to you? Or like what happens if your board comes to you and says, hey, actually, we want to do this?
would say I'm in the tech optimist camp. Like, I'm in tech because I think it can do good things for people. And if I didn't think that was the case, I wouldn't do it. You know, I think at the end of the day, you just have to decide, why are you in the business? You know, people can make decisions on their own, but for me personally, it's just not something that I'd be comfortable doing.
Why are you in the business?
I've done a lot of different things. I'm not someone who had a life's work. Melonee has been in robotics longer than I have. Jonathan, one of our other co-founders, certainly has been in robotics longer. My goal, you know, my wife and I always sit down before I do a startup. This is my second. And the first time she said, "What's your goal?" I said, "Learn a lot and don't go broke," which is always a worthy goal. I'm sure as a typical founder.
Take that as advice, guys.
For this, though, it was go big or go home, and specifically I wanted to see us sell 1,000 of something that no one had ever sold 1,000 of before. And that's specifically I wanted to see us sell 1,000 of something that no one.
Because that can churn out 10,000 a year?
That's the peak capacity, yeah.
Right. That's more than 1,000. I'm not a mathematician, but...
It seems like that, yes.
Yeah. Why is that exciting to you, to build at scale and to get many of these out there?
Yeah, I mean,
why is that exciting to you, to build
been in this rodeo before, you know, with Fetch robotics, and you know, I've already been through the journey and I really loved it and I wanted to do it again. And I've already been through the journey and I really with kind of
the next evolution of kind of robotics automation for logistics. So, you know, robotics automation has been going on since the 1960s, so we're about 60 years in. And we went from fixed industrial automation to mobile, which I spent a lot of time in, and now we're doing mobile manipulation, and I think it is the future, and I'm super excited to be part of it.
Yeah. In a lot of the kind of broader automation industry, there's a lot of conversation about jobs, job security, scariness around that. You know, I think most recently I saw that 6% of all people in the US work in trucking. Well, a lot of those jobs are about to go bye-bye. Yeah. And that sucks for those people. So there's retraining, there's early retirement, a lot of those kinds of things. This robot starts to look an awful lot like a human being. What's your take on that? Like,
Yeah, so I spent the better part of the last decade deploying mobile robots, right, in logistics. And when I started in 2014 with Fetch Robotics, there was a 600,000 job gap. So that means that they could not find 600,000 people to do the jobs in logistics and manufacturing. In that time, the gap has grown to 1 million people. So, and in all of the time that we deployed robots at Fetch Robotics, we never replaced a person because every single time we were just trying to fill a gap, a growing, never-ending gap. And so I don't see this, like, this problem happening right now because the workforce is aging, people don't want to do these jobs, and the numbers are showing that annual growth in, you know, the job gap is getting larger and larger in the United States and abroad.
Yeah. And so when you say these jobs, what are the jobs that Digit is able to fill that currently people aren't?
Yeah, so the Bureau of Labor Statistics, the BLS report, includes material movers, freight movers, hand manual movers. So these are people that are moving pallets of goods, moving individual goods, doing picking activities. Basically, anything that's required to get an item out of a facility, like at Amazon or any of these places, from a truck to a shelf, into a box, onto a truck, and to your house. So that's what's encompassed in all of the BLS data for material movers and hand workers.
So you're mentioning Amazon, and I imagine that if you are Amazon and you're building a brand new warehouse, you're probably going to build it mostly for the robots. So where does Digit fit in for that? Or maybe I'm wrong. Feel free to correct me.
Go ahead.
Yeah, I mean, I would say the interesting answer is no. And, you know, certainly Amazon's an investor of ours, so just be clear, I'm not speaking on behalf of them. A lot of these facilities right now lack good ways to glue automation from different system providers together. And a great example of this was the demo that we showed at ProMat, which was pulled from a customer application where we had a gravity feed of totes that we had to move to a conveyor. You'll end up in a lot of these cases with very specialized, very highly optimized solutions for these material moves moves that aren't by themselves attached to each other. And so when you set up a factory, interestingly, even in a greenfield construction site, you're going to end up with these gaps that right now are filled by hand labor.
Yeah.
Yeah, and Digit's kind of the automation glue between the islands of automation when you really look at it. It's really helping connect those disparate pieces, like Damion said.
Yeah. So I did a panel earlier today on this very stage about Intrinsic and their work around connecting. Like, I feel what they're trying to do is to build a kind of hardware agnostic approach to all of this. And whenever I say hardware agnostic, that's the response I get from roboticists. What do you need to do to program a digit?
Do you want? Should I take this?
You are the CTO.
Yeah. Well, so right now, since we're in early deployments with customers, there is a lot of black box to the deployment. We're working towards more visual programming languages like Intrinsic that help basically distill down the workflow logic of go here, do this, into something that is easily composable. And a lot of other companies have done a lot of work in this space. And so this isn't something that is, groundbreaking rocket science. I think that the big thing is it comes down to long-term customer engagement and getting to the parts that are the most meaningful to the customer. Because Digit, as you saw, has a ton of capabilities. And making sure that we can get to the right level of composability for the workflow that the customer cares about is what we're kind of dialing in today.
Yeah.
I can tell you about a bad bet that I made one time.
I would love to hear about your bad bet.
The bad bet was that we could think of the robot like a smartphone where people were actually pushing binaries to it. And so we had originally structured some of what we called the applications engineering team with this eye towards composing monolithic applications with the eventual thought that, well, maybe this is exactly what customers would do over time. Think of how smartphones have evolved, right? So people forget that the iPhone didn't launch with an app store, but now it's sort of the core feature of smartphones. We've changed our thinking, and when Melonee's talking about the primitives, we now actually don't even use apps as the parlance when we're talking about it. We call it skills now, where there's these much, much larger building blocks that abstract away a lot of the core requirement of, quote, needing to code on the robot,
Right.
and make it a whole lot more generalizable.
Right. Yeah, I mean, I don't want to control each individual actuator on a robot. It wouldn't be able to stand up, right?
Correct,
So at some level, I have to be able to tell it, like, can I program it?
Yeah, you can, actually. So Bambi, one of our senior software engineers who does human-robot interaction, actually had some elementary school students programming the robot using a visual programming language.
I think they're probably smarter than me, so it's not. But that sounds really cool.
Yeah,
so
it was amazing.
What level of programming is it? Like, go over there, pick up bucks, put bucks there, or?
Exactly, it's of those skills primitives. Yep.
Cool. And to what degree can it kind of do stuff autonomously? It's like, hey, go pick up speaker, put speaker over there, kind of thing. Like, or do you have to be pretty specific about what the task is?
So Digit is an autonomous agent, right? And so what we end up doing is part of the workflow construction is we give it like a task list, right? And we say, these are the tasks that I need you to do, and they're parameterized. So typically, the way this works in industry is like, there's the WMS, this cloud-based or whatever system that holds all the magical data that tells you where everything is. And so the
WMS stand for?
Warehouse management system. Or you can have a warehouse control system. They have all sorts of acronyms. The alphabet soup is large and vast. But when you get down into it, that system, this black box system, talks to our system. And we basically have a workflow that says, go here, do this. And basically the go here, the here part, is populated by communication from this other system.
Right.
And so when you have a workflow that is, Digit goes to a shelf, takes a tote off of it, and brings it to a conveyor, basically the WMS is saying, this is the tote. And then when Digit does that, then it says, oh, this is the new tote. And then Digit does that. And so you can imagine a set of instructions that go to Digit, which is get tote, where tote is from here, walk to conveyor, place on conveyor, get empty tote, put back where you just took that tote, grab new tote, start again. And so, and that's a very simple way of doing it, but it allows you to do some very complex behaviors with the robot.
Yeah. I feel like one of my first jobs was actually in a paint factory, and I was instructed exactly like that. Get barrel, move barrel. Like, yeah, that's cool. And this is the thing. The person who gave me those instructions would not, in theory, have been able to program a robot. But if it
or program you personally. Like, they're not going to puppeteer you, right?
Right. Well, the robot is not going to sit on a stage 20 years later and tell a grumpy story about a bad manager, hopefully. But there is a piece to this where even the people who don't necessarily know how to program robots are able to program robots. Yes. And I kind of, like, and the more the robots start to look like a human, like it's roughly my height, roughly my weight, roughly my everything, like that becomes really interesting because you end up having a very similar relationship with these robots that you would have to a worker, perhaps.
Yeah, we see, we get, as I'm sure everybody does, 20 questions today about, are you using LLMs for anything?
Right. Are you using LLMs for anything?
In the full deployments, no, because AI observability right now and safety issues mean that we're not using those techniques outside of a few very limited cases. So there are some machine learning RL approaches that we use on the robot in full deployments, but not generative AI. But the interesting thing about this, and there's a video on our YouTube channel that we showed some very early rough work with this, is precisely that if you layer a modern generative AI on the top end, it's not puppeteering the robot. The data rates are way too low to do that out of even relatively good LLMs these days. But what it can do is provide that task specification, get barrel, carry barrel here, and compose more natural language tasking into a set of commands the robot can execute.
Mm-hmm. And so how far are you away from, like, is that something that is desirable even?
In the long term, probably.
Right.
In the short term, again, for safety and observability reasons, no.
And when you say observability, does it mean that if the robot does something it's not meant to, you don't know why?
Correct. That's a classic AI problem.
Right. And so how does that show up? Like, what are you worried about?
Well, I mean, we're probably worried about different things, but in my case, we do have standards. We are right now the world leader in robotics and have been for the last 3 years, at least insofar as humanoids are concerned. Mm-hmm. So I think, like with the weaponization, we had to have the opportunity to decide what the future looks like. Mm-hmm. And one of the things that we want to do is say, no, we're not going to be irresponsible about this. We want to roll the robots out, work with our customers and the standards agencies to get robots safely into an environment. One of the characteristics of that kind of successful action is being able to tell people, here is exactly how safe the robot is. Mm-hmm. So in some cases, that means we put a laser fence around it if people have access to it. In other cases, it may be very safe to be next to the robot. It's going to be very task dependent and very specific, and we don't want to leave a lot of that open to AI systems that even people who are much smarter about it than I do kind of head scratch and say, well, I'm not entirely sure why I drew a picture of a cat when you asked for a mouse.
Right.
So yeah, that's my answer.
Well, I'm glad you say it's relatively safe because we just squeezed by here and I was like, what scares you?
Yeah. So when you look at learning systems, the biggest thing is can you, for the things that matter like safety, can you have complete determinism? Mm-hmm. Because you want to know that it's going to do the right thing every time. And so one of the problems sometimes with learning systems is you have a lot of inputs, you have probabilistic goo inside, and then you have outputs. Mm-hmm. And the problem is getting determinism out of probabilistic anything is like it's a non sequitur, right? Like those two words don't make sense. And so when you look at where we most likely will apply it is trained models that are then used, and then we can evaluate for determinism and then apply. Mm-hmm. And I've done this in the past with my last company. So I know it can be done, and you can get it safety certified to do that, so that's great. Right. But then also, like, there are lots of areas where safety isn't involved, and then it can be super empowering, like all the things that we just talked about for like, do this, go here, like, those types of business logic activities could use things, expert systems like ChatGPT to define the workflow and help a non-expert user construct a workflow that maybe they didn't have all the ideas for how they would get done, like for metric or business logic that they couldn't figure out how to describe themselves, but an expert system could help them describe.
Yeah, or even something like go get the red box, right? And then actually understanding what that means, understanding to go get a box or whatever.
Yeah.
And the other thing that when you're talking about learning, the thing that springs to mind for me is that in the human learning process, making mistakes is a really big part of it, right?
But if you can do it in simulation,
Right.
it's a better place to make mistakes.
I've never been able to simulate my own behavior, but for robots, that might be the way to go.
Well, and that's a really comical one, is because typically most learning systems learn through negative training examples, because humans learn a little bit differently, right? When we see a dog as a child and we learn that something is a dog, we also see 1,000 examples of what is not a dog, right? But in training robotic systems, we don't have all of that luxury, and so we'll say, that's not a dog. But it gets more complicated when you talk about safety. It's like, okay, don't hit things. And what's the robot going to do? Learn to hit something, and you're like, oh no, you shouldn't have hit that little kid. Like,
right.
That's kind of an after-effect thing that you don't want to happen. And so training some of these systems from a safety perspective is hard when you're using negative reinforcement.
Yeah. And so does that mean that you have to be particularly conservative about what you allow a robot to do at any given time?
Right now, yes. I think that a lot of the safety standards, particularly, are generously I can say they're trying to catch up. But when you look at most safety standards, they really don't even conceive probabilistic systems as part of the way that we even think about safety. It's like, it must do X and then Y and then Z. And if it doesn't do those things, it can never be safe, kind of thing.
Right.
And so now the safety standards community is starting to figure out, like, oh man, this is reality, so we got to figure this out because it's not going away.
Well, and I suppose with a human-shaped robot, you end up in a situation very quickly where thinking of it as a cobot becomes makes a lot more sense.
Yeah.
Where you are a human being that's operating in a space alongside this robot in one way or the other. Yeah. Is that a use case that you guys are exploring?
In the much longer term, yes, but I think there's an awful lot of work to do in industrial environments before we get to that point.
What does a much longer term mean?
I'm not well known for having the world's best calibrated crystal ball, but I would say that's probably a post 6 to 8 year kind of time frame. But again, that's a guess.
And I guess that your bet is that while you work towards getting there, there is still a large market for robots doing robot things while humans do human.
Well, yeah, I mean, as Melonee said, right, in the time that she's been in the field, there are actually more jobs that need to be filled over time. So effectively, industrial automation has made no progress and has in fact lost ground over the last 10 years.
Yeah, that makes sense. I think it's funny as well when you're talking about robot safety and somehow there's a Venn diagram there between that and the OSHA regulations. I'm like, wait, these are robots. Aren't they meant to be able to be in dangerous spaces?
Yeah, so OSHA applies to worker safety, right? And if a robot is in its environment, in a person's environment, that's a worker. And so the robot has to comply with safety related to that worker. Now, if workers were to suddenly leave the entire facility, it still doesn't solve all the problems because eventually someone has to go in and fix a robot.
Right.
Right? Like, if we get someday magically to the point in which robots are fixing robots that are in its turtles all the way down, then we're good.
Right.
But up until that point, OSHA is most likely going to be involved because at some point someone will be servicing a robot. And if you look at the jobs that are like growing in the robot service, robot technician, robot builder space, they're growing very fast because there's a lot of robots to be built.
True, yeah. What was left on the backlog? Like what didn't make it into Digit where you wish you could push the boundary or push the envelope for what
probably several hundred things.
Let's go through the first 50 or so.
Something that we did very successfully with the Cassie robot, which was our early research platform. It had very, very highly dynamic motion. And so we just were able to set a Guinness record for the fastest bipedal robot running a 100-meter dash.
Right.
Digit is probably capable of running but it's hard to tell. And when you start to add upper body complexity to it to actually make it do useful work for customers,
Right.
you can start to dial back some of the core dynamic features that we had in earlier versions of robots. So I think there's always a balancing act. When we look at when we look at things like battery life, there's always a question: how much battery do you put in? That's a question like how much food do you take backpacking? If you take a lot, you walk really slow, but you can stay out for a long time. If you take a little, you can run really fast, but have a limited number of nights out. So there's all these trade-offs that are sort of conflicting at all times requirements for the robot.
How far can Digit backpack?
Probably 6 to 7 kilometers as a guess. I don't know. We haven't tried it. We have actually a fun stat, which is it's walked about 27 marathons worth of steps since the ProMat show. So that's pretty exciting. We think that's probably the farthest that bipedal robots have ever walked.
That's because you keep walking it all the way to these shows.
Yeah, back and forth, back and forth.
Yeah, totally. What do you wish had made it into the final robot?
Obviously, a reality sensor. I mean, I think that the thing about any roboticist is they're always going to want more sensing. Like, we want all the bells, all the whistles, all the LiDAR. But as Damion said, like, we have realistic power constraints. And the fact of the matter is like, great, we have all that data, but then we can't get it off the robot because eventually it needs to go to a customer site. And I don't know, most customers don't like it when you have, maybe 50 robots and all of a sudden you've taken down all the bandwidth, right? So there is a real trade-off that you have to make in terms of, great, we have all of this perception capability, but what can we actually do with it in the long term? And so balancing the practical realities, but it could make the robot super cool, like, but
it's already super cool.
Yeah, yeah. I mean, from a geeky robotics perspective,
yes.
Not from a,
Okay.
Yeah.
Well, I think a big hand for fun and exciting robots. And thank you so much for coming.
Thanks. Appreciate it.
Cheers.